everyone, welcome to our YouTube channel. Today we are going to discuss about root cause analysis. Learning outcome will be introduction of root cause analysis, case study relating root cause analysis, need of adopting root cause analysis, example of root cause analysis, root cause analysis triggers, categories of root cause analysis, importance of carrying root cause analysis, steps of root cause analysis, root cause investigation tools. Now I will start today's topic with introduction of root cause analysis. Root cause analysis is an incident investigation method that analyzes the underlying causes of a problem. It is a powerful tool that empowers organizations to proactively address the underlying causes of a problems and failures. It helps in finding the root causes of the incident or accident after analyzing all the causes. Firstly, it identifies all the direct causes and then analyze each of them in turn to find out the underlying causes and finally the root causes, as it helps the employer in getting to the root cause of a problem so that they can implement solutions or control measures by targeting the source of the problem, and thus helps in solving the problems at the root level. The root cause analysis should be conducted as soon as possible after an incident, as it provides the most accurate information before details are to be forgotten. Root cause analysis focuses on processes, not individuals. It takes into factors the underlying cause or causes that triggers a chain of events that lead to an accident. By correcting underlying problems, the organization not only eliminates the root of the problem but also the sequence of the general and immediate causes that it generates, leading to a reduced risk of injury or accident, reduced costs due to the prevention of lost time injury, LTI, expensive employee litigations or regulatory fines, etc. Let us understand why it is necessary to solve the problem at the root level. Here is a case study. Let us suppose an example of a workplace. There was a truck which was parked in an organization that was leaking some oil. Because of this, there was an oil patch on the floor, and after some time this truck passed from the area. Still there is an oil leakage, and there was a worker who is working at the location, and he is using the mobile phone while working in the site. As he was not concentrating on the path, he walked on a slippery floor. He slipped, fell, and resulted into serious head injury. So this is the accident that happened in the workplace. After completing the investigation, the person carrying the investigation stated that the accident mainly happened because of an oil patch, unsafe condition, and a worker using a mobile phone unsafe act. After that, the organization takes the step for cleaning up the oil patch and installing the signboard that no mobile should be used in the premises or workplace. Do you think the accident will be prevented here? No, the accident is not fully prevented from reoccurrence because there is still leakage of oil from the truck and still the workers might use mobile phones. So for finding the permanent solution of this problem, the organization has to carry root cause analysis (RCA) as taking action on immediate causes such as unsafe act and unsafe condition is not sufficient for removing the problems and preventing them from recurrences. We can now further understand the need of adopting root cause analysis by this diagram in detail. This is a diagram of the accident weed. Root of this weed are the root causes of any incident or accidents, and leaves are the immediate causes. Immediate causes are due to hazardous practices, that is unsafe act, and hazardous conditions, that is unsafe conditions. Hazardous practices, that is unsafe acts, are rushing, ignored safety rules, not following procedures, failure to use safety equipment, inattention, etc. Hazardous conditions, that is unsafe conditions, are missing guards, cluttered work area, defective tools, equipment failure, poor lighting, etc. Root causes are generally organizational factors such such as no funds to purchase equipment, poor workspace design, rules not enforced, limited staffing, PPEs not purchased or provided, procedures not developed, no follow-up or feedback, lack of training, no safety leadership, etc. If we only cut the leaves of this weed, that is, we only take steps for removing immediate causes, then the chances remain that the root of this weed may grow and thus creating immediate causes to rehappen the incident or accident. So, permanent solution of preventing accident recurrence is only possible when we remove the root of this accident weed. This is an example of how root cause analysis is carried out after an accident which resulted into the damage of the equipment. Here, firstly, all the direct causes of the accident are analyzed, and for each direct causes, analysis is done for finding the underlying and root causes due to which damage to the equipment has occurred. In first column, LN2, that is liquid nitrogen, is kept in normal tank despite of keeping it in a cryogenically insulated container such as Devar or bulk tank, which are designed to store and transport liquid nitrogen at extremely low temperatures. As a result of this, an accident may occur. This diagram showing circle also represents the basic event which occurred due to equipment failure that required no further development into more basic fault or failure. In second column, it is shown that there may be chances that valve remained opened after the technician performing test and resulted into the accident. In third column, accident occurred due to pipe leak. Why pipe leak? Due to seal failed. Why seal failed? There are two chances. There may be defective seal or no maintenance is performed. Why no maintenance? Because there was no maintenance procedure. And why no maintenance procedure? There is no budget allocated to create procedure. Let us see another reason of seal failed, which is defective seal. And defective seal is due to quality inspection not performed. And the reason for why quality inspection is not performed was that there were not enough quality personnel, which is a root cause of this accident. Now, let us see fourth column. The immediate cause of the accident was found that the quality did not detect the leak. Why? Quality personnel looking at different location. Why quality personnel was not present at the location? Because they are doing many tasks at a time. Why doing many tasks? The reason was that there were not enough quality personnel, which is a root cause of this accident. Let us see the last column or fifth column. The immediate cause of this accident was the equipment was kept under pipe, and the reason for this act was the insufficient time was provided for put the equipment away. And why insufficient time provided? Because too many tasks scheduled. This is the explanation how root cause analysis is done. During carrying out root cause analysis, we see all the possible immediate and underlying causes why this accident happens, and finally we go to the root causes after doing analysis, as we know that there is always a root cause behind an immediate cause of the accident. So when we remove the root cause of the accident, the chances of the accident recurrences can be minimized or completely prevented. Now, I will discuss about root cause analysis triggers. These are some examples after when we have to perform a root cause analysis: after a workplace injury or illness, after a safety related equipment failure, after a chemical spill or release, after a vehicle or driving related incident, after a safety violation or rule breaking, after a near miss that could have caused harm. These are the different categories or types of root cause analysis done for different purposes. Safety-based RCA. This type of RCA is used to examine and identify the root causes of any failure of safety compliance, accident analysis, or other issues related to occupational health and safety. Production-based RCA. This type of RCA is used in manufacturing industries to investigate and identify the root causes for issues such as product defect, production bottlenecks, or recurring problems within the manufacturing process so that quality of the products can be maintained. Process-based RCA. This type of RCA is used to identify the fundamental causes of problems within a process which causes inefficiencies and disruptions so that this can be prevented from recurrence. Failure-based RCA. This type of RCA is used for failure analysis. This is typically used in engineering and maintenance. It is used for identifying the mechanical failures that lead to equipment malfunction. System-based RCA. This type of RCA is combination of two or more methods of RCA. This approach is used to identify root causes of the failures which are associated with the field, such as change management, risk management, and system analysis. Following are the importance of carrying root cause analysis. Finding the long-lasting solution. Root cause analysis help in finding the problem at the root level, and thus it helps in finding the long-lasting solutions. Achieving goals on time. Root cause analysis is used to measure the challenges an organization is facing, and after finding root causes, they should address the issues by updating their processes, and thus helps in achieving its goal on time. Implementing best corrective measures. After identifying the root causes of a problem, the organization may develop more effective strategies to overcome that problem by adopting the best corrective measures. Preventing the recurrence of the incident. After conducting a root cause analysis and implementing their solutions, it helps the organization to significantly or completely prevent the same or similar issues and incidents from recurring. Increasing the public trust. After finding the root causes and implementing the solution, public trust may increase as they show that the organization is taking prevention more than merely treating problems by surface level symptoms only. Attracting high performing employees. After adopting this technique, the organization will have an incident free record, which may help in attracting and retaining high performing employees. Improving efficiency. Root cause analysis helps organizations to identify inefficiencies and loopholes in their processes. By eliminating the root causes of these issues, the organization can update their systems, optimize resource allocation, and enhance overall process efficiency and effectiveness. Reducing downtime. Root cause analysis help in finding the causes of equipment failures, downtime, and disruptions. By solving the issues of this failure, the organizations can minimize their unplanned downtime, increase productivity, and optimize the utilization of their resources. Minimizing cost. As the root cause help in finding the causes of failure, thus it helps in preventing repeated failures. By minimizing repeated failures, cost associated with repeated repairs, replacements, and operational disruptions can be reduced. Identifying systematic issues. As root cause analysis goes beyond identifying individual causes and looks for systematic issues within an organization. So, by analyzing the root causes of problems, organizations can discover patterns, trends, or common factors that contribute to multiple issues. After that, they implement systematic solutions that address the broader underlying issues and thus improving overall system performance. Mitigating risks. By using the technique of root cause analysis, the organization can identify and resolve underlying issues by mitigating risks and preventing potential hazards. Thus, the organization can prevent accidents, failures, and other costly incidents that can pose risks to employees, assets, and the environment by using this technique. Facilitating continuous improvement. Root cause analysis is a fundamental tool for driving continuous improvement within an organization, and it gives opportunities for optimization, implement process enhancement, and foster a culture of learning and innovation. Now let us discuss how to conduct a root cause analysis or the steps of root cause analysis. Following are the steps of root cause analysis. First step is to define the problem. Firstly, we have to critically analyze and clearly articulate the source of the problem to diagnose or isolate the situation as the first step of a containment plan. Then we gather data. After clearly defining the problem, we proceed to the second step of gathering data. We have to compile, brainstorm and map data to each process for analyzing the causes of the problem and finding the factors that lead to its occurrence. Third step is determining the root causes. After gathering data, we proceed to identify the root cause of the process that caused the problem utilizing RCA tools like the Fishbonediagram, 5 whys, Pareto charts and more. Fourth step is test recorded solutions. After finding the root cause, solution of the root cause is decided by verifying the solution. We verify to find out which solution will eliminate the problem permanently. We utilize measurable standards to test the identified cause and effect to take action to permanently fix the problem. After finding solution and verifying the solution, implementation of the corrective action is done. We turn into actionable strategies. We methodically incorporate corrective action to contain the problem and prevent reoccurrence. Last step is the sharing the results. Lastly, we document the results of the RCA findings and share the resource to standardize safety processes and training. Following are the root cause investigation tools: 5-why analysis, Fishbonediagram, fault tree analysis, FTA, event tree analysis, ETA, bow tie analysis, Pareto chart analysis, failure mode and effects analysis, FMEA, scatter diagram, affinity diagram, root cause mapping, 8D problem solving, change analysis. Thank you so much for watching. Please don't forget to like and subscribe.